Let's take a look at some examples. For the first example, find the equation of the tangent line to the graph of f of x equals to x squared at x equals to 2. Okay, let's find the slope m. The slope is the same as the derivative, so let's use the limit definition of derivative. Okay, so here x equals to 2, and I just applied the limit definition of derivative. Okay, so this will be the limit as h approaches 0, f of 2 plus h. Plug that into f. Plug in 2 into f. All over h. Okay, now let's square this out. And 2 squared is 4. Okay, let's simplify here. The 4's cancel out. So that's the limit of 4h plus h squared all over h. Okay, and the h cancels out with the h in the numerator, like this. Okay, so the limit of this as h approaches 0 is the same as 4 plus 0. And that's 4. Okay, now the point on the graph at x equals to 2 is 2, 4. Okay. Use the point slope formula. Okay, this is the point slope formula. I'm just going to plug in what I got for m, which was 4, and y0 equals to 4, x0 equals to 2. Okay, solving for y, I get 4x minus 4. Okay, so that's our tangent line. Here is a graph of our original function, y equals to x squared. It's a parabola, and the point at 2, 4 is here. We just found our tangent line to be this, and we see that it is indeed a tangent line at x equals to 2. Let's look at one more example. Find the derivative of f of x equals to 1 over 3x at x equals to 4. Okay, so we want to find f prime at 4. Let's apply the definition of the derivative. It's the limit as h approaches 0, f of 4 plus h minus f of 4 all over h. Okay, now let me plug in 4 plus h into our function f of x. Plug in 4 into our function. That whole thing divided by h. Okay, now let's rewrite this here. 3 times 4 is 12. Okay, let's combine these two fractions. Bringing them under a common denominator. And don't forget the whole thing is under h. Let's multiply the 3 to each term here. Okay, and let's combine this h with the denominator here. The 12s cancel. Okay, the 3 cancels out. The h's cancel out. Now from here we can just plug in h equals to 0. The reason is because this right here is a function of h and it's continuous as long as the denominator is not 0. And since h is approaching 0, the denominator won't be 0. Okay, and because this is a continuous function, the limit as h approaches 0 of this function is just that function with h plugged in as 0. Okay, so here we just plugged it in. Okay, so the limit equals to negative 1 over 48.